Hello, my name is Brant Rolston with LoadSlammer, and in this video I'll be discussing how a LoadSlammer can be used to reduce the number of capacitors in a design. Reducing capacitors in your converter is an effective way to save board space, money, and reduce the number of difficult to find parts, and a LoadSlammer can be a valuable instrument in this endeavor. However, everything must be done carefully and intelligently. Here are the basic steps. First, it is important to accurately define load transient requirements in terms of step sizes and current slew rates. Knowing where you are at is key to knowing where you can go. Don't settle for an arbitrary number, as it may cause you to leave money on the table. Next, test the converter with the LoadSlammer to see how it reacts. Measure worst case at the critical load, as this testing includes PCB trace resistance. If there is margin before exceeding regulation limits, then your circuit is a candidate for reduced capacitance. Proceeding from here requires knowing the control methodology of the converter. I will divide these into three types: hysteretic/semi-hysteretic, internally compensated, and externally compensated. Semi-hysteretic converters are known by a variety of terms, including constant on time as well as various trade names. They typically do not have a specific control loop, being voltage triggered, or else have an internally compensated loop in addition to hysteretic control. Either way, the manufacturer's datasheet and application notes will often define a range of recommended output filters. Always stay within your manufacturer's guidelines. If you find that your circuit is on the high side of output capacitance, try reducing either the value or number of capacitors, testing with the LoadSlammer after each reduction to verify operation within specifications, and with minimal ringing and overshoot. Leave some margin so that the production and component variations don't push the performance beyond limits. Verify that the reduced output capacitance doesn't increase output ripple voltage excessively. For internally compensated converters, voltage mode, current mode, or proprietary mode, reducing output capacitance follows the same method. Always stay within the manufacturer's recommended guidelines. If you can do that, reduced capacitance, and verify good performance, the slammer will have likely already paid for itself. Externally compensated converters are more involved, in that design software or simulation must be used to optimize design and predict performance. However, potential reductions in output capacitance are often greater. A slammer can help identify a marginally stable converter and can verify an optimized design. However, that is outside the scope of this video. Now that you've watched this video, you should be familiar with the use of LoadSlammers to reduce the number of capacitors in a design and the benefits of doing so. For more information about LoadSlammers, including where to buy one, visit LoadSlammer.com.